making sure that you're showing the work correctly. All right, because your answer is worth a half a point, or full point, but all the steps along the way are a half a point. So if you're skipping any steps, you're going to get a lot of half a points taken off, and that makes a big impact. All right, so page 199, you said 35, right? Awesome. So 35 said, we have 28 s to the 15th divided by 42 s to the 12th. All right, what I like to do on these, I like to rewrite them and spread them out just so I can see what goes with what. You don't necessarily have to do that, but I like to do that so I can see it. All right, so first of all, we need to simplify that fraction. All right, the power rule does not apply to this fraction. We just need to divide out common factors, DOCF, between these two. 28 and 42 of a common factor is 7. So the 28 becomes a 4. The 42 becomes a 6. They also now have a common factor of 2. So that 4 becomes a 2, and the 6 becomes a 3. So I divide out common factors between the 28 and the 42. Valentina, take notes, please. All right, that way you have some in class that we're doing, and you can kind of catch up as you're sitting in class, okay? All right, so I divide out common factors between the numbers in the fraction. So for now, I have 2 in my numerator, I have 3 in my denominator. So Brendan, are you cool with that? Okay. Now, I have s's in my numerator, I have s's in my denominator. So I'm dividing two numbers with the same base. I keep the base in the numerator, and I subtract the numerator exponent minus the denominator exponent. All right, so I end up with 2s to the 3rd over 3. Does that help you? Awesome. What else can I do for you guys? Molly? 62. Let's take a look at 62. So 62 said I have 15x to the 6th divided by negative 3x squared. Is this the one you're talking about? Okay. So I'm just going to rewrite this, spreading it out. So I have 15 times x to the 6th over negative 3 times x squared. I'm going to do my fractions, my number part of my fraction first, and then my variable part of my fraction second. So if I divide out common factors between the 15 and the 3, well, they're both divisible by 3. So my 15 becomes a 5. My negative 3 becomes a negative 1. All right, so I have 5 in my numerator. I have negative 1 in my denominator. My x's, I have x to the 6th divided by x to the 2nd. So I keep in my numerator the x's. There's no more x's left in my denominator because I'm doing that dividing out of common factors. Remember, we have 6 of them in the numerator, 2 of them in the denominator. If I divide them out, I have that 6 minus 2. All right, well, 5 divided by a negative 1 is a negative 5. And then x to the 6 minus 2, which is 4. And I do want to see it like that, not like this. This is simplified, that is not. All right, the one below it, I think, had negative 7 divided by negative 1. Well, negative 7 divided by negative 1 is a positive 7, so I need you simplifying that too. Questions? You guys cool with these? Okay, get your notes out. Let's move along. So we're adding more power rules to our list. What I like to do is summarize as we go. So I'm going to put really quickly list what the ones we've already gone over, so you have them in one place, and then add to that list of the new one we're going to do today. Alright, so today is 12:9. We are in Chapter 4, Section 6. And we're going to be talking about negative and zero exponents. Your test will be at some point next week, probably towards the end of the week. We are definitely getting it in before break. Okay. Well, let's review where we've been. So these are our power rules as we know them so far. Our first one is when we are multiplying numbers, parentheses variables, with the same base. So that would be like a to the m times a to the n. Alright, off to the side I'm going to write this. We keep the base. We add the exponents. So this would be a to the m plus n. AJ, I need you keeping up with us. Alright, if I did an example of that, let's say I have x to the third times x to the fifth. This would be x to the 3 plus 5, which gives me x to the 8th. Alright, the second one we did is when we are dividing. It's only two numbers, and I'm going to put in parentheses variables, with the same base. So that would be like a to the m divided by a to the n. Alright, we keep base in numerator only. So that would be a in my numerator, a 1 in my denominator. And we subtract the exponents. The key thing I want you to keep in mind is it's your numerator exponent minus denominator exponent. I need you to remember that because when we do some today, your numerator exponent might be smaller than your denominator exponent, and you're still going to do that order, numerator minus denominator exponents. So this would be a to the m minus n. So that's just a quick summary of where we have been so far. All right, so let's take a look at negative and zero exponents. All right, I'm not just going to give you the rule. I want you to understand the rule because the negative ones are a little bit harder to grasp until you really see it and you're like, oh, that makes sense. Who needs to see what's up there? All right, math is all about patterns. All right, it's all about patterns like I showed you when we're dividing two numbers with the same base, right? If we had an example, let's say I have x to the 10th divided by x to the 6th. Let's not make that 10th because that's going to be too big. Let's make that x to the 5th divided by x to the 3rd. Well, that's x times x times x times x times x, right? Divided by x times x times x. So our power rule is doing that, dividing out common factors. That's x to the 5th minus 3 over 1, which is x squared, which makes sense. It's a pattern. All right, so math is all about patterns. And remember, I'm not looking for you to do the expanded form, but I want you to understand that we are looking at patterns in math. All right, so we're going to go through some patterns for you guys. Cullen, sit up. We're going to go through some patterns right now. And we're going to figure out what negative exponents mean and what a zero exponent means. All right, so what I want to do is we're going to analyze patterns in the following. All right, so give yourself some space. So if I have 2 to the third, this is exponential form. So writing it as 2 to the third is exponential form. If I was to write that in expanded form, what would that look like? What does x to the third mean in expanded form? Sophia? I'm sorry, 2 to the third. How many of you guys are cool with that? Okay. All right. This, if we wrote it in standard form, I haven't explained that one to you. Standard form is when we actually do that multiplication. Well, what is 2 times 2 times 2? Or 2 to the third? Sarah? 8. Okay. So now what I want to do is, I'm going to take 1 off of my exponent. So I'm going to subtract 1 from my exponent. So this is minus 1. So my new exponent is going to be a 2. You guys cool with that? All right. Well, if I subtract 1 off my exponent, that means I'm dividing 2 out of my expanded form. So I'm left with simply 2 times 2. I'm going to put that in pink also, because I want you guys to see it. All right. Well, what is 2 times 2? What is my standard form here? Ada? 4. All right. Well, if I was to do that again, what is my next exponent down? If I subtract off 1, what's my next exponent now? Amanda? That's 2 to the first power. All right. Well, that also means that I'm dividing off a 2 from my expanded form. So I'm simply left with 1 of my 2's, which is why it's 2 to the first. That makes sense. Well, 2 to the first is simply 2. Are you guys cool with this? Okay. So if I continue that pattern and I subtract a 1 off of that exponent, what is now my exponent? So 2 to the first minus 1. What now is my exponent? Colin? 1 minus 1? 0. So here is my 0 exponent. I'm going to put a big star there. Well, to go from my expanded form down to the next one, I was dividing by 2. Well, what's 2 divided by 2? Cameron? 1. So 2 to the 0 power is 1. All right, we're going to keep going here. If I subtract off a 1 from my exponent of 0, what is now my exponent? AJ, what's my exponent? Yep, so this is going to be 2 to the negative first power. Okay, so let me ask you something. If I'm dividing 1 by 2, dividing by 2 is the same thing as multiplying by a half. Do you guys agree with that? How many of you guys agree with that? Dividing by 2 is the same thing as multiplying by a half. Okay. So what does 2 to the negative first power mean then in expanded form? Ada? I don't want it as a decimal. I want it as a number. Isn't that a half? What's 1 divided by 2? Isn't that a half? Okay. So 2 to the negative first power is 1 over 2 to the first power, which is 1/2. Let's do this again. All right, I'm subtracting a -1 from my -1. What is my new power if I have -1 minus a -1? What's -1 minus a -1? Valentina? Yep, 2 to the -2. Well, I'm going to take my 1/2 and I'm going to multiply it by 1/2 because I'm dividing by 2 each time, which is the same thing as multiplying by 1/2. If I was to write that in expanded form, I get 1/2 times 1/2, which is 1 over 2 to the second power, which is 1 over 4. I'm going to use this as our help. So let me rewrite that. I have 2 to the -2 power. That is equal to 1 over 2 to the +2 power. I'm telling you these two are the same thing. Are you guys good with that? So these two are the same. So without continuing on with this whole process in this table, if I said 2 to the -3rd power, how can I rewrite that with a positive power? Because if you've noticed, I took 2 to the -2nd power and I changed it so I now have a positive power. What is 2 to the -3rd power going to look like? Alex? Not 1/2. 1 over?
2.
Excellent. If I had 2 to the -10th power, what is that going to look like with a positive power? Sophia? Yes. So what we've done here is we have changed the negative powers to positive. And you're thinking, why do I need to do that? All right, to apply a power, the power has to be positive. So to apply a power or exponent, the power must be positive. You can't apply a negative power. You just can't. All right, so to simplify 2 to the -2nd power, I have to change it into 1 over 2 to the +2nd power, and then I know that's 1 over 4. All right, so let's write this power rule. We actually have 2 power rules here that we've just discovered. All right, let's write both of them. Who needs to see what's up there? All right, and we're going to apply these so it becomes a little bit more natural to you guys and see it in its real situations. All right, so it says what we did is we changed negative powers to positive, and to apply a power or an exponent, it has to be positive. The base doesn't have to be positive. The power has to be positive. Colin, open up your eyes. If you feel like you're falling asleep, I want you to go stand or sit on a high top or stand in the back of the room. If you feel really tired. Okay. All right, so let's write our rule down. So this is our 0 exponent rule. This is the easier of the two. There's nothing complicated about it. Any number or variable to the 0 power is 1. So a to the 0 power is 1. Alright, so that's my zero exponent rule. Alright, and let's talk about, this is more complicated, negative exponent rule. So if I have a to the negative m power, how can I rewrite that with a positive power? Colin? So go back to what we were just doing the last couple ones.
It would be like
1 over a to the m. Right? Keep that keep the base, keep the power. Power becomes positive. All right? If I have 1 over a to the negative n power, how can I make that a positive power? So in the first one, that a to the negative m power is in my numerator. I moved it down to the denominator, that base and its power to the denominator, and made the power positive. Addie, how am I going to make this positive? In the numerator, right? Yeah. All right, so if I was to summarize this rule, what you're going to do is you're going to move the base and the power to its opposite location. What that means is numerator to denominator, that's an n, or denominator to numerator, and then you're going to make power positive. So there is the last rule. Okay, so let's practice a couple of these. Patrick, I need you sitting up. All right, so let's do an example. I want you to write the expression using only positive exponents. All right, so I have 3 to the negative 5th power. What is that going to look like with a positive exponent? Addison? 1 over 3 to 5th. Because it said with positive exponents, I'm not going to put that in standard form. Sit up. I don't want anyone laying down. Sit up. So I don't need to go any further. If it said simplify, I would do 3 to the 5th power. Okay? All right, how about m to the 0 times n to the negative 4th? Well, what does m to the 0 equal? Patrick?
1m.
Not 1m. M to the 0 power. What's any number to the 0 power? 1. So I simply have a 1. All right, now simplify my n to the negative 4th. Alex?
1 over n.
Yep, so I'm just going to do 1 in my numerator and then n to the 4th in my denominator. So I only needed to move that negative power. You guys cool with that? All right, let me give you guys another one. How about 16x to the negative 6th y? What base has my negative power? Coral? The x. So the x is the only one that needs to move. So x is only variable / number that needs to move. So somebody rewrite this with all positive powers. Amanda? Where does my y go? Doesn't it stay in my numerator? Isn't this y to the first power? So isn't this 16y? So that stays, doesn't it? Yep, so that 16 and the y both stay in my numerator. And then my denominator, I agree, is x to the 6th power, positive 6th power. You guys cool with this? All right, let me give you a couple to simplify. So let's kind of run through what we did here. On these last two, it's really important that you recognize when you've got a lot of things being multiplied or divided, isolate each one and see what do I need to do with this. The 16 had a power of 1 on it, it stays where it is. That y had a positive power on it, it stays where it is. The x has a negative power, it has to move locations. Okay. All right, so I want you to simplify this one. Five to the 10th power times 5 to the negative 6th power. So now you have a couple power rules that I need to be using. All right, you have two options here. You could use multiplying two numbers with the same base. How many of you guys agree that we could do that? Okay, so I'm going to show the two different options. So what I could do is I could do 5 to the 10 plus a negative 6, right? Which gives me 5 to the 4th power. Off to the side, it's 5 times 5 times 5. This is 25. It's 25. 25 times 25 is going to give me 25 times 25. I think that's 425. So that's 5, carry the 2. That's 12. Same thing. Right? No, that's not 12. It's 11. Let me do that again. That's right. That's 5. That's 2. That's 12. That's 10. Carry the 1. Here we go. That makes more sense. That's going to be 5. So 625. So this ends up being 625. If I don't use my multiplication power rule, what else could I have done instead? So this is one way that I can do it. What's another way that I could have simplified this? Addie? Yeah, so I could do 5 to the 10th divided by 5 to the positive 6th. If I did that, now what? If I did that method, now what? Ada? I need to use my power rules, which gives me 5 to the 4th, which gives me my 625. Can you see that you could use the different power rules in different ways, right? And it doesn't matter which way you do it, which way you see. You may be like, I don't want to deal with negative exponents, so make them positive, and then use your power rules, right? So there's a couple different ways that you could do it now that we have a couple different power rules. All right, let me show you another one. So let's say I have 6k to the 3rd divided by 2k to the negative 9th. All of you guys simplify that. Remember, simplify your numbers, then simplify your exponents, or your variables. going to divide out common factors between the 6 and the 2. 2 becomes a 1, the 6 becomes a 3. What did you do after that? So I have a 3 in my numerator, I have a 1 in my denominator. What did you do after that? Colin, what'd you do? What power rule did you use to start with on your variables? And where'd you put it? So you did this, times k to the 3rd times k to the 9th? You can't flip them. What's the power on my k in the numerator? Positive or negative? So it has to stay there. Right? Doesn't have to stay there? I'm so glad that you did that because I want to make sure that I catch any of those. That k to the 3rd has to stay where it is. How many of you guys see that? The k to the 9th, it can move, can't it? Because it's negative. So if you use your negative power rule here, you would have 3 times k to the 3rd times k to the 9th. Now what would I do from there if this is the way that I did it? Cameron? Okay, and what's my final? Excuse me? 3 times k to the 12. All right, who did not use the negative power rule here? Who did something different? Molly? Talk louder, please. Okay. Excellent. Okay, so it's not 3 plus 9, it's 3 minus a negative 9. Which, once we do adding the opposite, I do agree with you, it's plus a positive. But make sure you understand it's 3 minus a negative. So in this one, Molly used our division power rule instead. How many of you guys thought to use the division power rule instead here? Yeah, absolutely could do that. So Molly, what does that give me as my final answer? Excellent. Can you guys see that now with a couple different power rule options, you have different options of work you can do, as long as you use them properly. Are you guys cool with this? I like these. So I'm going to be giving you guys harder ones, like combining many of the power rules into one where you've got to be really careful and you've got to take one step at a time. All right, these to me are fun. I know they may not be fun for you, but these to me are fun, so I'm going to give you fun ones to do. So please understand these power rules. All right? Okay, my odds, you can go.